Have you ever wondered where the materials around you come from? How the chemical elements were discovered and where they're found? How they're mined and refined into finished products? And how we rely on chemicals for all that we do and how they affect our lives and our environment? Students at the Mountain Land Applied Technology College in Orem, Utah are answering these questions in The Elements Unearthed, our discovery and usage of the chemical elements. Many U.S. businesses that rely on a steady stream of STEM graduates are already finding it difficult to recruit enough adequately prepared people. For example, NASA anticipates that over 30% of its technical workforce will retire in the next 15 to 20 years, and there are not enough U.S. students in the education pipeline to fulfill the coming shortage. Some businesses are taking matters into their own hands by supporting programs that would help to train their future recruits, such as direct grants to schools, challenge competitions, or teacher professional development programs. NASA has created the NASA Explorer Schools program to train teams of teachers and administrators from schools and to provide direct grant support to improve their science and technological infrastructure. Let's look at this numbers gap. According to the National Science Foundation Division of Science Resource Statistics, the number of students receiving Bachelor of Science degrees in science, technology, engineering, and math increased during the 1970s and early 1980s, then saw a rapid decrease overall, except in biological sciences, with some improvements recently in computer sciences and mathematics. Physical sciences and engineering graduate numbers have remained static at best in the last 20 years, with only a slight increase lately. Keeping in mind that the U.S. population has continually increased over this time, the fact that science and engineering graduates have in general decreased from the high points in the 1980s is alarming. We are putting out fewer scientists per capita than we did 20 years ago, just at a time when we need these professionals more than ever to keep our place in an increasingly globalized and competitive world. The need for citizen science. Ultimately, the major problem is the divide in our society between those who do science and understand it, and those who merely use the technologies it produces without understanding it. We are becoming a technocracy, a population ruled by the few people who design, control, and maintain technology. Altogether, scientists and engineers make up about 0.85% of the total U.S. population. In other words, of 100 elementary students in school, only one of them, on average, will go on to a career as a scientist or engineer and be actively engaged in creating science or technology. These few people are solely responsible for discovering the majority of the new knowledge and technologies our country relies upon. If we were to map out the relationship between the amount of fundamental new science created on a vertical axis and the percentage of the population involved in this creation horizontally, we get a steeply sloped Pareto curve. Yet beyond the narrow band of professional scientists and engineers lies a long tail of semi-professionals or generalists, including college science and engineering professors who are only part-time researchers and high school science teachers, as well as amateur scientists, which include college and secondary science students, and the citizen scientists in the general public. All of these people could potentially be creators of new science and technology. In the chart shown, the total amount of science produced can be represented by the area under the curve. What would happen, though, if we found a way to move the level of acceptability to the right to include science conducted by part-time researchers, generalists, teachers, students, and even citizen scientists in the general populace? We would dramatically increase the total amount of science done and enlarge the depth and breadth of the research conducted. We would also engage a larger segment of the population. Of course, there are many issues to resolve about how to train the amateurs and semi-professionals to do accurate, valid, repeatable science, and to broaden the access of these studies to publication. A similar type of curve exists in the field of educational content creation. Currently, most content provided in classrooms is produced by professional curriculum designers. Yet a long tail exists of semi-professionals and amateurs, including teachers and students, and even experts in the general public who can contribute content that is equally valid and much richer in subject matter and variety than the professionals. The major issue here is quality. How can amateurs be expected to produce professional results? Yet the potential exists for better quality and variety than what is currently available. The quality of textbooks, lesson plans, and other curricular materials produced today is good, but it's not excellent. By making these materials acceptable for a mass audience of varying reading abilities and backgrounds, publishing firms produce mediocre results. No one would ever pick up a textbook and read it for fun because of its gripping narrative. By opening up content creation to non-professionals, we broaden the variety and the range of quality produced. One of the Element Unearthed project's outstanding features is that the collaborating teams will produce their own content in the form of video podcast episodes. They will be trained how to research, plan, script, film, and edit digital images, video, and audio. We use podcasting as our format because it engages both audio and visual senses and encourages and motivates students without having to worry about publishers, agents, printing fees, distributors, shelf space, and other barriers to access that are created by the current economics of scarcity. We will take advantage of the infinite shelf space and economics of abundance provided by the Internet. In addition, students will take ownership in what they learn and have pride in accomplishment because their work will be of high quality and seen by an unbounded audience. Quality and accuracy will be maintained through the subject matter experts each team will consult and through peer reviews as other teams critique their work. The so-called Web 2.0 technologies, including podcasting, are beginning to transform the world, giving everyone the tools and power to become producers instead of consumers of educational materials. Students today will actively participate in their own education by creating much of their own experience and content. They already interact and collaborate using these technologies, and their usage will spread to education and will revolutionize how we teach and how our society operates, changing students into teachers and teachers into mentors and facilitators. This movement will democratize everything as all information becomes digital and available online. If we were to chart the continuum of educational activities that are provided in a science classroom, the old chart would show passive education on the left, such as taking notes while the teacher lectures, and active education on the right, such as hands-on, inquiry-based labs. But the continuum should be extended to include a third category: the creative students who evaluate and critique existing knowledge, then create new knowledge and content through themselves becoming scientists and media designers. The tools are already in place, and in the next 10 years, we will see a transformation in educational practices as more classrooms are structured to facilitate the creative student. This transformation should invigorate and enliven science and engineering, as new voices add new knowledge and new media beyond what the professionals can now do. It may seem daunting to attempt to increase participation in authentic science across the country. Surely our project can't do this all by itself, but it can make a start and add to efforts already out there. If all we can do is to simply encourage one more student to pursue a career in science and technology out of every 100, we will double the amount of science and engineering done. This should not be too difficult a task.